Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects titled Multiple Decision System-Based Multicast Routing in Mobile Ad-Hoc Networks. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Hello friends, welcome to TechPacks Research and Innovation Services. Today I'm here to present you one of the protocol that we have designed by using the fuzzy soft computing technique for taking the decision in route selection in the wireless communication. So let's move to the video. Before moving to the video, let's talk about that what we will cover into it. In this video, we will talk about the application areas where the developed system can be useful, then whatever the code we have designed, how to execute it, which file you need to run, and what are the software requirements to run that code will be there. Further to that, we will discuss that what are the current systems, those who are working in the same domain, and the problems identified with them, and what exactly we have done in the proposed method. Finally, an experimental outcomes and findings will be discussed to give the results. So let's talk about the application areas. Uh, the application area is related to the wireless communication where the mobility of the nodes is there, that mobile ad hoc networks where on-demand networking for the communication is to be required. So it is not restricted to any one of the single domain. So it is related to the movable sensor areas, for the medical, for the smart buildings, for the movable cars, so aerospace, computers, biomedical application, smart agriculture. So all these domains covers under it, so where the data is to be transferred from one location to another and route selection is to be made. So let's move to the code now. So we do have the folder name code which we are going to give you, under which all the files has been placed. The whole code is implemented in the MATLAB, so you must have the MATLAB software installed on your system. So in order to run the code, you just need to go to the folder, just copy the path, go to the MATLAB, and here you just need to paste it and press enter. When you press enter, you can see all the files can be seen here. The MATLAB version that I'm using here is MATLAB 2019A, so you can use 2015 or the higher version in order to run the code. So out of this, there are a number of files over there you can see. So we do have the two scenarios. One is mobility node, another one is the node variation code. Along with that, the fuzzy system has been implemented, under which we do have different fuzzy systems here you can see, and finally a comparison is being done. So now in order to run the code, you just need to select the file and click on the run button. It will start processing the whole code and will show you the outcomes, and you can save it by using the save command which I commented for now in order to do the comparison later on. Same I done for the second scenario where the number of nodes are to be entered by the user and you can save the results. So in order to run the mobility, you just need to click on the run button. The fuzzy systems will be initialized. It will ask for the mobility. So from the base paper there were different mobility variations, so you can enter those similar values in order to do a comparison. Let's say the mobility I'm entering is 5, so it will process the system and will ask you for the source and the destination node number. So let's say when it will ask, I will take the source 25th and destination as a 13. So 25th and 13, press enter. So you can see it formed a route from 25th to 13 with the PDR value of 95.9. Similarly, if I'm going to do it with the node, it will show me the result. So now let's talk about that, what exactly we have done. So we have considered this base paper in which they have used the fuzzy control system for the multi-constraint multicast routing in the wireless ad hoc networks. What they have done, they have considered the fuzzy logics in order to take the decision with the three parameters. The parameters they were considered was delay, bandwidth, and the energy, and on that behalf they were calculating the cost. So the node with the least cost was selected as a next hope, rest all will get deselected. So the problem that we identified is, one of the thing is like the parameters they are considering are less in count, so it should be more, and so that in order to achieve the quality of service, but at the the same time, if the parameters are going to be increased, a single fuzzy will create an issue. So we have created the multiple fuzzies, divided the section factors into two categories. Then now, as because of the two fuzzy, we need to give one decision. So we have implemented stage 2 of the fuzzy, which is taking decision from the individual and making it one. So it is a multi-stage fuzzy logics, right? So let's talk about what factors we have implemented in the proposed. For the proposed method, we have used energy, delay, bandwidth, congestion, and PDR. And the system design is quite like this, in which three of the factors, that is delay, energy, and bandwidth, are taken under one fuzzy, congestion and PDR under two, and whatever the outcomes come out from the two, that is passed to the weight based scenario, where W1 is given to the input of output of the fuzzy logic 1 output, and weight 2 is given to the output of the fuzzy logic 2, and finally we are getting the overall cost, which help on deciding the optimal route. So now let's have a look to the code. So initially the fuzzy system are being generated. So one of the network is where the parameters like energy, delay, bandwidth is defined, and the fuzzy cost is calculated, and all the rules has been defined. The second is where the PDR and congestion is as a input, and fuzzy cost is given, and the rules has been defined. So both the files has been called here, so you need not to run these separately. So these will be called here, and on that we have the network initialization, the network nodes has been implemented, the energy model is implemented, mobility model is there. So you need to enter the mobility, because in the base paper they have analysis with the change in the mobility and change in number of nodes. That's why we have considered the two scenarios. So mobility is there. After calculating all the factor, energy, throughput, and all related factor, the distance, the all the information saved in the node this, and then when the source node and destination node has been given, on that we have when we have evaluated the individual parameter for the each node with the two different fuzzies. So eval phase is the valuation of the fuzzy. So this is fnet1, fnet2, and whatever the outputs comes out, we multiplied it with two weightages, which we set to the 0.6 and 0.4. We give the mode weightage to the energy and those factors, and congestion and PDR will be given as a 0.4 weightage. Now when source and destination will be given, it will check for the cost that we have extracted on, and node with the higher rating to be selected as next stop will be selected, and on that we have calculated the parameters. So in the second scenario, all the code is similar, only the node count is to be changed. Finally, for doing the comparison, we have run it for multiple scenarios and did the comparison with the base paper. So you can see when you will run the comparison code, it will show you the outcomes. So here you can see in the proposed scenario, the MFSRP is our proposed one. So packet delivery delay, it is less in our case. Similarly, for the packet delivery delay, when compared to the traditional methods, the black curve is down, which is better. Similarly, packet delivery delay, it is better as the mobility is changing. The packet delivery delay is increasing for the proposed scenario. This is packet delivery ratio, which is higher in our case, black curve. Similarly, when compared with the traditional, it is higher with respect to all the other one. Same as the mobility moves, the packet delivery is dropping a bit. So similarly for the packet delivery ratio, by changing the number of nodes, comparing with traditional, and so on. So further modifications are still possible. For that, you can contact us directly and can get the information. Thank you. Thanks for watching the video.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPacks, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.